Regioselectivity in electrophilic aromatic substitution. Regioselectivity means we are trying to find out in which position the electrophile will get substituted in the aromatic ring. Let's consider a benzene ring with a substituent here, X. If this undergoes electrophilic substitution, where will the electrophile attack? Will the electrophile attack the ortho positions or the meta positions or the para position? So this is what we are trying to find out in regioselectivity of electrophilic aromatic substitution. Remember, electrophiles are electron loving, so they are going to attack the spot in the aromatic ring that has high density of negative charge. So the rule is that electron withdrawing groups on the aromatic ring favor electrophilic substitutions in the meta position, and electron donating groups on the aromatic ring favor electrophilic substitutions in the ortho and para positions. Now let's start with toluene. Toluene is a benzene ring with a methyl group. Now alkyl groups are electron donating, so toluene should be directing the electrophile to the ortho and the para position. Carbon in the methyl group is sp3 hybridized, and that is electron donating or has less electronegativity compared to the sp2 hybridized carbon of the benzene ring. This is called as inductive effect, and it is a positive inductive effect or plus I effect because it's electron donating. Also, there is hyperconjugation between the sigma bonds of the CH and the pi bonds or the p orbitals and the p orbitals of the carbons in the benzene ring. So if we have toluene, the hyperconjugation happens like this, and the ortho position gets a negative charge. And this can have resonance structures, and this ortho position gets a negative charge, and the para position can also get a negative charge. So this is hyperconjugation between sigma bonds of CH and p orbitals of the benzene ring. So because of this, toluene is orthopara directing. Next is anisole. Anisole is a benzene ring with a methoxy group. So as you can see, you have the electron withdrawing oxygen, which can give a minus I effect or negative inductive effect. But however, the possibility of the oxygen undergoing resonance with the benzene ring, or the possibility of the non-bonding electrons in oxygen undergoing resonance with the benzene ring, called as mesomeric effect, is more powerful than the inductive effect, and that's why Anisole is orthopara directing. So this is the plus M effect, mesomeric effect, is more powerful, stronger than the minus I effect. So we see how in the resonance structures the negative charge gets concentrated in the orthopara position, making it orthopara directing. Methyl benzoate is C6H5 COO CH3. Now here the carbonyl group can be electron withdrawing. It will be meta directing, and so this is electron withdrawing. And so meta directing. Benzaldehyde carbonyl groups are always electron withdrawing, and so they will be meta directing. Acetophenone again electron withdrawing, and meta directing. Phenyl acetate. Phenyl acetate is CH3 COO C6H5. Now, because of these electrons on the oxygen that can undergo resonance with the pi electrons of benzene, it concentrates the negative charge on the ortho and para positions. So phenyl acetate is ortho para directing. Acetanilide the lone pair of electrons on nitrogen can engage in resonance with the benzene ring, leading to acetanilide being orthopara directing. Chlorobenzene. Now, though chlorine is known to be more electronegative than the carbon in the benzene ring, it's found to be orthopara directing because there are two forces in play. There's definitely the minus I effect or the negative inductive effect because of chlorine's electronegativity. But however, the mesomeric effect of the electrons that can participate in resonance, the non-bonding electrons of chlorine that can participate in resonance are more powerful, rendering chlorobenzene orthopara directing. Aniline. Aniline is benzene ring with an amino group. So as you can see, this lone pair of electrons on nitrogen can undergo resonance with the benzene ring, and so it can activate the ring to be orthopara directing,